Hello Engineering 10. Today we're going to talk about schematics. So, what the heck are schematics? Not sure if any of you have ever encountered them before or not, but schematics are used pretty much universally to describe or to plan out a circuit. So today we're going to learn how to read schematics. So if you ever hope to own a house, or obviously become an electrical engineer, or pretty much any kind of a computer engineer, then being able to read a schematic is going to be crucial. And in fact, in this class, in Engineering 10, your final summative project in the electrical engineering unit will require you to read a schematic. So what are schematics? They are circuit drawings. They are used virtually, I guess I've never been to every country in the world, but as far as I know, they're used in every country of the world that has electricity and electronics circuits. They can be quite complex, used to describe circuit boards like this one here that I've got on the screen. They can be used to to describe the electrical circuit inside your house. They can be used to describe simple circuits, but they are used to be able to design, build, and ultimately troubleshoot circuits. So understanding how to read them is really, really important for engineers. So the first step to be able to read a schematic is to know what the schematic symbols are. So a schematic is made up of connections and symbols, just like in pretty much any spoken language. Languages are made up of words, and those words put together can form meaning. But the words themselves, on their own, they don't really do a whole lot, but they represent something. And so that's what a schematic is. A schematic symbol, schematics are made up of schematic symbols, and schematic symbols are like the words in a language that represent something. Some schematic symbols have multiple ones. We'll deal with one in particular in this class, but they should be pretty much universally recognized anyway. Okay, so there are lots of schematic symbols out there, as you can imagine, because there's a schematic symbol for probably every electronics component. We're not going to deal with them all, but we'll deal with a few, and I'm going to highlight some of them here. So first of all, there's the resistor. You know and love resistors. You can tell me how to read, or you can read a resistor. You can talk to me about how bad beer rots our young guts, but vodka goes well. Well, these are the schematic symbols. One is American and one is the symbol used by the rest of the world. So resistors, we'll deal with them. Variable resistors, we'll deal with them, and in fact you've already dealt with variable resistors. Potentiometers, even light-dependent resistors, although they have their own specific schematic symbol. And there it is, the schematic symbol for an LDR or a photocell. It looks kind of like a little photocell. We also have a battery down there. So any kind of a power source, obviously, we need to be able to identify what those are. We have fuses. So we dealt with fuses way back early in the unit when we were able to try, or when we were trying to figure out how much current was flowing through that circuit, and we used fuses to see if they were between 3 amps and 5 amps. We've got some wires down there, wires that are joined and wires that are not joined, and we'll talk about why we need both of those in a minute. You also have a push button switch. You've dealt with those. You've dealt with, well, that's a regular switch, the type of switch that you might find in a house. You've got single pole double throw switches right there. We also have LEDs and the NPN transistor. The transistor you're going to learn about in the next lab, and it is really, really important. And so again, it's a three-legged component with 3 legs on the schematic symbol. Okay, so those are the schematic symbols that we're going to look at. But what's the purpose of a schematic? It's a quick way of sketching a circuit. It's a quick way of representing a circuit. It's a quick way of being able to troubleshoot a circuit if you've got a good schematic, because you know what gets connected to what. They don't tell you how to put the components together, they just tell you what gets connected to what component gets connected to what component. And so in any kind of a schematic, it does not tell you the shape of the finished product, but it does tell you just what component gets connected to which component. So let's get into it. So first of all, most circuits are made up of, well, they have connections. That's how you connect all the different pieces together. And connections are usually wires, and wires are represented in a schematic because they have to be. And if they're connected, that's very, very different, obviously, than if they're not connected. So a connected wire is usually soldered together or plugged in through a breadboard. An unconnected wire is just a wire that is crossing over another one, but is not actually soldered together. It's not making a connection. So it's not connected. But sometimes, obviously, if you're building a circuit that has multi-layers, like in a house, you've got multiple floors, sometimes wires actually lay on top of each other, but they're not actually connected, and they're separated from each other by, well, the insulation around the cable itself. And so, in circumstances where you've got a circuit with wires that cross over each other, or at least a schematic with wires that cross over each other, but they're not actually connected, we usually would indicate those by a little loopity-doop like this, or a broken line. Now, I don't love the broken line schematic symbol because sometimes if you've got an old schematic that's been photocopied multiple times, you can't tell if that's actually a disconnected or not connected wire, or if just a poor copy. But connected wires are usually indicated as such with a dot over them. Okay, some other major components. Obviously, resistors are really, really important, and we've got two different schematic symbols for the resistor, which I know is a bit frustrating. The one on the left is the US version. The one on the right is the international version. We, being in Canada, we're so close to the US, but also influenced by Europe, we need to know both. Next up, we have potentiometers and other variable resistors. So the one on the right is the potentiometer, and you are all experts at potentiometers. You know how pots work. You know that they're a little variable resistor that varies based on the position of the dial of the knob. And so in the schematic symbol, it looks just like a resistor because it's got the American, at least, version of the schematic symbol for a resistor with a little arrow that's pointing in, and that arrow is essentially the finger that's going in to turn the dial. Other variable resistors have a similar schematic symbol. It's got the resistor except with a sloped arrow going through it. Okay, so make sure you know potentiometers at least. Okay, next up we have our switches. So this is a single pole, single throw switch. And so remember, the pole is the thing that the connections that can be made, and the throw is the thing that actually moves. So in this case, we've got one thing that moves, and it's only got one connection that can be made. So a single pole, single throw switch. So if that is a schematic for a single pole, single throw, what do you think would be the schematic for a single pole, double throw? Think about that one. So single pole, double throw means that it's got one connection, but two things that are moving, two throws. So how do you think you'd represent that schematic symbol? What about a double pole, single throw? I'll give you a minute to think about that, and then I'll show you some examples. Okay, here's what some of those schematic symbols would look like. We just saw the single pole, single throw. Here's a single pole, double throw. So one pole, two different ways that it can move. So it can either be connected to this part of a circuit or this part of a circuit down here. Here's a double pole, single throw. So now we've got two things that are moving, but they're only ever connected to one part of the circuit. Then S4 here is a double pole, double throw. And so in that case, we've got two poles that are moving, two throws that are moving, two poles that they each can be connected to. All right, next up are our power sources. So there's not much of a circuit if you don't have any power coming to it. And so we've got four different power source schematic symbols here. The one top left would be a 5-volt DC source. So that's probably some kind of a cell. Over on the right, top right, we've got a 120-volt AC power source. That's what's coming out of the wall. Down at the bottom, we've got a couple of different battery schematic symbols, and you'll notice that there's a pair of lines for each battery cell. So bottom left, we've got a single cell battery. Bottom right, we've got a double cell battery pack or power source. And so if you had four 1.5 volt batteries, AA batteries, then you'd have 4 sets of lines there. The long line indicates the positive side, the positive terminal, and so that's important when you're trying to read a schematic, because you need to know, obviously, if you've got an LED, for example, in series with one of those batteries, you need to know that the anode has to be on the same side as the long leg of the battery, or the line that indicates the battery schematic. Next up, we've got a diode. So that, or actually that's a light emitting diode. No, that's not. That is a diode. This one is a light emitting diode. So diodes and LEDs. Diodes are, we haven't really gone over them in class. That becomes more of a thing for the Engineering 11 class when we learn how to drive motors. But a diode is a very important component, electrical component, that allows current to flow in one direction only. And so that becomes really useful when it comes to motors, because we can allow the current to flow into the motor to spin it, but then you may know that a motor is also able to become a generator and generate an electrical current that goes back up a circuit. And that can actually damage microcontrollers or other components that are on the other end of the circuit. So if you use a diode in series with a motor, then that will allow the current to get to the motor to spin it, but it'll block the current coming the other way. So very, very useful. So a diode essentially is this. This is the schematic symbol. It shows the direction of the current because you've got a little arrow there, and so that is going this way. It blocks it coming the other way. You'll see that there's actually kind of a little line that indicates that it's blocking the current. Now, a light emitting diode is a special type of diode that actually lights up when you've got current going the right way. It also blocks current going the other way because it blows. The little light will pop, and it'll block the current. It'll prevent the current from going back the other way. So the difference in the schematic symbol are these little lines that are coming out, little arrows that are coming out, which indicates light. Okay, so exactly the same schematic symbol. The light emitting diode, the LED, has arrows coming out of it. Okay, next up is one that we haven't covered yet in class, but you're going to cover it in the next lab, and that is the transistor. So transistors are pretty amazing, but I won't steal my thunder for the next lab. We've got an NPN, which is what we're going to use in class, as well as PNPs. They are 3-legged devices. They're really, really important. Without them, we don't have the electronics devices that we have, but they've got a collector, or at least the NPN has a collector that collects, an emitter that emits, and a base that controls it all. And then the PNPs are very, very similar, but well, we'll get into that a little bit more tomorrow, but they've got an emitter, a collector, and still a base. Okay, so if you have a schematic that has several resistors in it, for example, how do you know the difference between, how do you know if it's a 10 ohm resistor or a 10,000 ohm resistor? Because the schematic symbol is exactly the same, and you don't get to see the little lines on it to be able to read them, because there's no line, there are no colored lines that would have, black or brown or red. So you're not unable to identify the size or the resistance provided by that resistor. So the schematic symbol tells you some really, really important information, but it doesn't tell you everything. So you need to be able to name it, and as well as give it a value in order to make the schematic quite useful. So here, for example, is it might not be a terribly useful circuit, but it is a useful schematic because it tells you exactly what those 3 resistors are. So first of all, we've got a 9-volt battery. Actually, we've got a 9-volt battery pack, which is a bit odd. But we also have 3 different resistors, all of different sizes. R1, that's the name. R1, it doesn't make sense to name it Fred and Wilma, for example, because Fred and Wilma are not resistors, but R1, R2, R3, well, that kind of makes sense. LED1, LED2, LED3, that kind of makes sense because that's what they are. So R1 is a 3K ohms, so 3,000 ohm resistor. R2 is a 10,000 ohm resistor, And then R3 is a 5K ohm resistor. See how much more useful it is when you actually have not just the schematic symbol alone, but the value as well as the name. Because that way we can identify R2, for example. Replace R2, well now you know you're replacing the 10K ohm resistor. So the names are, well, the names go a long way towards being able to identify the difference between things if you've got several of the same component in a circuit. So, all that being said now you can put it all together to be able to read a schematic. And so if you take a look at this schematic here, it's a pretty simple one, but you'll get a lot more complicated than this. And in fact, in class, for your summative, it'll be a much more complicated schematic than this. So here we've got a 3-volt battery pack. We have one resistor that is a 220 ohm resistor, and it's probably connected to a, well, it's connected to a red LED. And then we can get up to more complicated ones like this. Okay, let's practice a little bit. What does this schematic represent? So think about it. Identify the parts. What's part 1? What's part 2? Part 3? Part 4? And you might even be able to identify what is likely an error in this schematic. Okay, so pause the video if you need some more time, but if you don't, you should see that part 1 is a battery, single cell battery. Part 2 is a switch. Part 3 is a resistor, don't know what size. Part 4 is, I expect it's supposed to be a light emitting diode, but it is just a diode at this stage. So it's a circuit that when you push the button will drain a battery. If it was a light emitting diode, if it had the little arrows coming out of it, then it would be a circuit that lights up an LED when you push the button. Okay, what about this one? This one's a little bit more tricky. Only 3 components in it though, but you have built this circuit. So what is it? So again, identify the parts. You should be able to identify the power source there as a single cell battery. We also have, hopefully you can identify the LED, because it's got the little arrows coming out of it, so it implies that there's light coming out of that diode. And then the third thing, what's the third thing? So the third thing looks a lot like a resistor, a 2K ohm resistor. But if that's a resistor, there's nothing connected on the other end. But check this out. Remember how there is a little arrow coming into one of those resistors? Do you remember what that was? The circuit that you've built here was our potentiometer circuit. So that's the pot. And so in that case, we've got the 3 legs, one leg that's connected to the LED, one leg, the wiper, that's connected to the battery, and then the other outside leg that's not connected to anything. So sometimes you actually have a pot that is connected with all 3 legs, but in this case, only 2 are connected. And the wiper would always have to be connected. Okay, what about this one? So hopefully you can trace what's going on in here. So we've got a little bit of a different schematic symbol for the power supply here. It's a power and a ground, but if we trace what's going on with the current, if it's flowing through the 220 ohm resistor, it goes out through the LED, comes along here, and this is quite clearly a switch. And so if it's switched this way, if it's thrown this way, then we follow the current down around this lower part, and it's an open circuit. So clearly that LED would not light up. If we throw the switch this way, so if the switch goes on to the right-handed connection, if that first switch goes to the right, then the current's going to flow through the 220 through the LED, and this time it's going to be connected through this and all the way back down to ground. So that LED would turn on there. Now we've also got this other switch here that if we throw it to the other way, then the current, assuming that the switch number 1, we didn't switch it back, we'd have an open circuit again. So what is this? This is a circuit with two switches that can be used to sometimes alternatively turn on that LED by two different power sources, or two different switches, I mean. But I say that you've used this many times. What is this? There you go. Does that look more familiar? If you at your house have 2 floors of living space, you probably have a circuit like that. Might not be a 220 ohm resistor that's protecting it. It might not be an LED, but it's that type of circuit where you can turn on the light from the upstairs or the downstairs. And that ends this lab. Now, I will also provide you a handout with several different schematics that you should be able to practice on, as well as a lab to be able to identify, as well as a handout to be able to identify all the schematic symbols that we just went through. So please take the time to fill that out, because that will be your reference for the summative schematic that you'll have to follow.